Good morning. Welcome to the lecture on biocontrol systems. In the previous lectures, we have been discussing on the introduction to signal flow graph and the conversion of signal flow graph from a given block diagram. If a block diagram or if a signal flow graph is available, how to derive a transfer function from that particular signal flow graph? We will focus our lecture towards that today. So at the end of this lecture, you will be able to derive transfer function for a given linear time invariant systems using signal flow graph. This signal flow graph, as rightly mentioned in the previous lectures, will have a formula. We call that as a Mason's gain formula, which looks like this. The given transfer function is represented as 1 by delta summation k pk del k, where t represents the transfer function of the system and p suffix k represents the forward path gain of the kth forward path. K represents the number of forward path gains in the signal flow graph, and delta provides you a brief idea about the actual system. Mathematically, we can represent delta as 1 minus sum of individual loops plus sum of the gain products of all possible combination of uh, 2 non-touching loops followed by 3 non-touching loops and goes on. Delta suffix k is a part of the graph which is also a resemblance of delta for a particular kth forward path. So if you are able to get all these variables from the given signal flow graph, we can finally get a transfer function for a given signal flow graph. Let us consider this problem. So we are supposed to derive the transfer function C of s by R of s for the given signal flow graph. So you know the transfer function is represented as 1 by delta summation k pk del k. Sometimes in some literatures they represent it like 1 by delta fk del k. It depends upon the literature. Now, what is a forward path? A forward path is the path from the input node traveling through different nodes to reach the output node without crossing the same node twice. For example, input node is 1, output node is 5. How many paths are there starting from 1, traveling through different nodes to reach this node 5? So as you analyze the signal flow graph provided, we can find 2 forward paths starting from 1 2 to 3 to 4 to 5. So the path taken is 1 to 2 to 3 to 4 to 5. What is the representation of this forward path? Let us say P1. Multiply all the gain elements available in the path. That will give you G1 into G2 into G3 into G4. Similarly, we have another path which takes 1, 2 to 3 to 5. It is not passing through the point 4. So I can write the path in terms of nodes 1 to 2 to 3 to 5. So we have 2 forward paths here. So accordingly my formula will change. My transfer function will be 1 by delta. Since k is equal to 2, your transfer function formula modifies like P1 delta 1 plus P2 delta 2. So we are supposed to find, we have found what is P1 and P2. We are supposed to find what is delta 1 and delta 2 to get the complete transfer function. Then based on the definition of delta can be represented as 1 minus the sum of individual loops plus the sum of the product gain of two non-touching loops. So what is a non-touching loop? A non-touching loop is two loops which are not having any common nodes. Okay. Similarly, for three non-touching loops, four non-touching and all, we are supposed to find. In some problems, it may exist. In some, it may not. So we write it like sigma PM1 plus sigma PM2 minus sigma PM3 plus it goes on. So sigma PM1 collectively says the sum of the individual loop gains. What is a loop? A loop is the signal starts from a node and it will end at the same node, passing through different nodes, not more than once. Let us take an example. The first figure given here, the signal starts from 2, goes to 3, then to 4, comes back again to 2. So it starts from the node 2 and comes back to the same node 2 without passing through a single node twice. So this is considered as a loop. We call them as individual loop. We have to find individual loop, find what is the loop gain, and we have to sum it. That is represented as sigma PM1. So this sigma PM1 can be expanded like P11 plus P21. This M is going to vary. Plus P31 plus etc. Similarly, sigma PM2 will be written as P12, P22 plus P32 plus etc. Sigma PM3 will be P13, P23 plus P33 plus etc. So we will consider the individual loop gains. So if you analyze the given signal flow graph, we can find 5 individual loops available. If you are able to write the node path, it is 2 to 3 to 4 back to 2 for this node. For this node, it is 2 to 3 to 2. For this node, for this individual loop, it is 2 to 3 to 5 back to 2. For this one, it is 2, 3, 4, 5 back to 2. And we call this as a self loop because it starts from a node and it ends at the same node without passing through any other nodes. This can be written as 4 to 4. Multiply all the gain elements available to write the value of this particular individual loop. So P11 becomes minus G2, G3, H1. Similarly, P21, P31, P41, P51 can get the gain values, multiply the gain values. Then to get sigma PM1, we can add all these gain values to form sigma PM1. Then we will go for sigma PM2, the gain products of two non-touching loops. Consider the first loop, individual loop and the second individual loop. Check the node equations 2, 3, 4, 2, 2. Here 2, 3 back to 2. Here 2 and 3 are common nodes. So they are touching loops. They are not non-touching loops. Similarly, we are supposed to compare 1 with 2, 1 with 3, 1 with 4, 1 with 5. Then 2 with 3, 2 with 4, 2 with 5. It goes on. This comparison will be going on. If you do that, we can find two set of non-touching loops. The first one is written as P12. P12 is nothing but the second loop and the fifth loop. We can combine these two as we see it is 2, 3 back to 2. Here it is only 4. We doesn't have a common node. Here only we are having node 2, 3 and 2. Here the node is 4, so we cannot find any common nodes available. So we can write P12 can be written as P21 into P51, which leads to this one, G2, G5 into H2. The gain values of individual loops are multiplied here. Similarly, we will get another set of non-touching loops. This loop 3 and loop 5. We can see there are no common nodes. 2, 3, 5 will be there in the third loop, and fifth loop you have only fourth node. So no common nodes. So this is again a non-touching loop. So we can multiply these two, P31, P22 can be written as P31 into P51. So we will end up with minus G2, G5, G6 into H3. We can add these two to form sigma PM2. Sigma PM2. After thorough analyzing, we are not having any three non-touching loops. To find three non-touching loops, take three individual loops and verify whether it is having common nodes. For example, let us take the first individual loop, second individual loop, and third individual loop. Here it is 2, 3, 4, 2. Here it is 2, 3, 2. Here it is 2, 3, 5, 2. So 2 and 3 are common in all these three individual loops. Similarly, we can find 1, 3, and 4. Then 1, 4, and 5. Then 2, 3, 4. Then 2, 4, 5. Then 3, 4, 5. Okay. If you do that analysis, you can see it has at least one common node available when you are comparing three loops. So sigma PM3 followed will be 0. It is not having any non-touching loop, three non-touching loops. So my delta can be restricted to the formula 1 minus sigma PM1 plus sigma PM2, which leads to this particular expression. We can combine all the values what we have considered, what you have found in the previous discussion. Now delta is known. We are supposed to find what is delta 1 and delta 2. What is delta 1? Check whether the forward paths available are touching all the individual loops. So already we know the forward path node equation is 1, 2, 3, 4, and 5. You can see all the loops are touching your first forward path. What is in touching by means it has common nodes. Compare this with individual loops. It will have at least one node common to them. So we can say delta 1 is 1. Then go for the second forward path. The second forward path, the node equation is 1, 2, 3, and 5. It is not touching the fourth. So the loop which is having only the fourth node as its node equation can be subtracted from the delta value. So delta 2 can be provided as delta 2 is equal to 1 minus that particular individual loop which is having only that fourth node. So the fifth individual loop is having that fourth only. So the gain value is going to be G5. So 1 minus G5 is delta 2. So we have found what is delta 1, what is delta 2, what is P1, what is P2, then what is delta. So substituting all these values, you can derive and finally get the transfer function as shown in the expression. So this is your final transfer function for the given signal flow graph. Thank you.